Hi, everyone. So I'm Tim Lau. I'm the Senior Director of Product Line Management for Marvell's Automotive Business Unit. I've actually been with Marvell now for a little over 5 years, but prior to Marvell, I was at Broadcom for 14 years. The last 6 of those 14, I was driving their automotive Ethernet strategy. So I've been lucky enough to be involved in automotive in-vehicle networking, specifically with automotive Ethernet, essentially since the beginning. And clearly, we are seeing very unprecedented times in the automotive industry, where vehicles are essentially becoming data center on wheels, whereas previously it was a very fragmented in-vehicle network with different domains. Networking technology basically centered around CAN bus, LIN bus, FlexRay, a little bit of most, very, very low bandwidth, and complete isolation of different specific functionality. Now the in-vehicle networking is changing very, very rapidly, where sensors and cameras are collecting huge amounts of data in the in-vehicle network. Instant processing is absolutely required for critical applications such as ADAS and autonomous drive applications, and higher resolutions of cameras and LiDAR and radar are increasing the need for higher bandwidth. And the only real industry standard for high bandwidth in-vehicle networking is Ethernet, and that's an IEEE standard, which generally the entire automotive industry participates in to drive next generation networking requirements. So Marvell, as a leader in automotive in-vehicle network connectivity, specifically on Ethernet, on the forefront of driving that technology forward. And a key piece of that is our product portfolio. Marvell has Ethernet technology, compute components, compute solutions. We have security as well as storage that can help transform the in-vehicle network and the in-vehicle environment significantly to achieve much smarter, safer, and greener vehicles. And you see a representation of where we see the next generation automotive network transforming towards, which is more a zonal architecture. We'll talk a little bit more on my further slides on how zonal architecture is really influencing next generation automotive topology design. So just a quick background on Marvell and our engagement in the automotive industry. So we're the fastest growing automotive Ethernet company in the world. We have industry leading products that can help develop the in-vehicle topology, which includes a secure automotive switch, which can be fully managed. We have a gigabit Ethernet standalone physical layer transceiver. We're already sampling a 10 gigabit automotive Ethernet physical layer transceiver that can also run in 2.5 gig as well as 5 gigabit. We're sampling an Ethernet camera bridge solution, and we have a strong focus on research and development, developing next generation products, and as we go along, generating the associated Ethernet patents as well. So very strong patent portfolio of investment in the in-vehicle networking industry. Overall, we have over 30 plus Brightlane products. Our Brightlane is the name for our automotive Ethernet product portfolio. We have 30 plus products in production today, and we have 30 OEM design wins, and 8 of those OEMs are out of the top 10. So significant adoption in the market today. So let's talk a little bit about the transition to a software-defined vehicle. So as I mentioned earlier, the original automotive in-vehicle network was very isolated, and it was extremely independent of each other, which was very, very challenging. And so, but moving forward, we see definitely an interest in automotive OEMs to move more towards a software-defined vehicle. And by that, we mean basically moving from a one-time buy to a pay-as-you-go type of model for the automotive OEMs. So instead of just buying the car, driving it home, and it's a one-time payment, the automotive OEMs would like to put together a model where there's additional services, additional features that could potentially be enabled over time, which the purchaser can then utilize and take advantage of, after the car's sale. And this includes things like the capability to support satellite radio, additional software services, and potentially advanced driver assistance features that can be enabled over the air. Okay. So the transition to software-defined vehicles is driving the need for better software and more lines of code. And so you can see here where we are, where the lines of code have significantly increased over time. So you can see here a comparison of various applications from aeronautics to consumer to automotive. And you see here the last three data points for automotive is that the million lines of code are increasing exponentially. So you're, once again, almost a 10x increase from a modern car today to essentially a level 5 autonomous vehicle in terms of the number of lines of code. And so that's what we really mean by a software-defined vehicle, is that these additional services, these additional requirements are driving significant increase in software investment and software flexibility capability. Now, of course, with that additional software and in conjunction with additional connectivity, there's then always the possibility for a greater security threat surface, meaning that there's the capability for a malicious attacker to try to attack that software or attack that connectivity and gain access or do something malicious to the vehicle. And so we'll talk more about some of the techniques that we've implemented, not just from a hardware perspective, but also a software perspective to mitigate or even prevent those attacks. So as I mentioned earlier regarding the zonal architecture, so the previous architecture was based on a point-to-point connectivity, meaning that every electronic control unit in the vehicle was connected independently on a point-to-point communication perspective. From a point-to-point communication perspective, you see a block diagram or a representation of that here to the left. And the thing that you notice right away is that with a point-to-point architecture, that the number of cables required or the wiring harness becomes extremely rigid and extremely complex and honestly expensive and heavy as well. So it's a myriad of cables because you have to connect everything point to point to the electronic control unit that manages that endpoint device. And this is why the automotive OEMs are working towards more of a networked and secure network based on a zonal architecture. And you see that representation on the right, where you have more of a centralized network that has cables connecting to whatever area that specific area that digital endpoint is connected to, and that then simplifies the overall network. It provides a very secure network because there's capability to support redundancy. It's highly scalable because, once again, you don't physically have to connect any digital endpoint to the managing electronic control unit. It can just connect to the specific zone or specific area that has the closest node. And honestly, it's highly intelligent, meaning that it's all based on Ethernet protocols and can share in the overall network. So really, Ethernet is the enabler to go from a isolated domain-based architecture to a zonal, highly secure, scalable, intelligent architecture. Okay. So let's talk a little bit about the safety and the security environment. So once again, as there's more and more code, more and more software, as well as more connectivity to the in-vehicle network or over a shared network, there is a need to ensure that security is implemented across the entire in-vehicle network. And there's several areas to secure from a software and hardware perspective. Obviously, the firmware image that's utilized to initiate and manage the hardware needs to be secure. Our device configuration, so that no malicious attack can actually change any of the critical configurations of the vehicle. Obviously, any data exchange needs to be secure, and then any redundancy and integrity safeguards has to be secure as well. And example threats are an attacker can try to prevent or alter the configuration. They can try to steal private information. That's a very hot topic right now with connected vehicles. Or they can try to disrupt traffic transmission and or reception. And so those are probably the biggest challenges from a security environment perspective. And so we have introduced, Marvell has introduced our third generation Bright Lane Automotive Ethernet solution or switch. And we actually launched it at Automotive Ethernet Congress this past month. And so it is a critical piece of our overall product portfolio because it is the most comprehensive and advanced Ethernet switch for the automotive industry from a security and safety perspective. We've implemented significant security techniques to mitigate, once again, all of the potential attacks or threats that we can get from a potential attacker. And one of the key ones is MACsec. So MACsec is very well known on standard Ethernet for the enterprise data center service provider space. But Marvell was the first to introduce it for in-vehicle networking. And MACsec essentially is a security protocol that we implement on the physical layer transceiver on layer 1 to be able to authenticate messages as well as encrypt and decrypt those messages all at the physical layer transceiver. And so this is basically ubiquitous in the standard Ethernet market on the enterprise side, and is now a key requirement, I would say, for the automotive industry moving forward for next generation architecture. We also have an embedded HSM. We also have an embedded dual-core lockstep microcontroller for redundancy, key exchange, key storage. It secures our layer 2 and encryption keys, as well as mitigates intrusion and man-in-the-middle and replay type of attacks, which are most common attacks on a network. So I'll quickly go over our block diagram. We have a data sheet, design guides, all of our reference collateral fully available for our third generation automotive Ethernet solution, and it is basically a highly integrated multi-port switch. It actually is a 9-port switch in this configuration with multiple integrated 1000 base T1 PHYs, 100 base T1 PHYs, and 10 base T1 S PHYs, which is the new standard for 10 megabit automotive Ethernet. As I mentioned, it fully supports MACsec on all ports, so we can once again authenticate, encrypt and decrypt data through our switch on every single port, whether it has a physical layer transceiver or not. I already mentioned the dual-core ARM R52, which can run in lockstep, excuse me, that is utilized for layer 2 manageability, quality of service, as well as such as AVB and TSN, and then also the secure key storage and management. We have the HSM, which is managed by the ARM core, which also contributes to the key management. And of course, it's fully automotive qualified and is in a fairly compact 15 by 15 BGA package. We have another configuration of our third generation switch called the 5192, which is a higher port count version. It actually supports up to 16 ports of automotive Ethernet. So whereas the 5152 supports 9 ports, the 5192 supports 16 ports, and really this is designed for autonomous drive applications, ADAS applications, as well as central gateway applications. But similar feature set between the two, because the 5192 actually is a multi-chip module, so it supports two 5152s encapsulated into a single package. Okay, moving on to our just high-level value proposition of our automotive Ethernet switch solution. It is it highly enables safe, secure in-vehicle networking. Once again, with the dual-core lockstep CPU redundancy for safety, we have the capability to run redundant paths through the ARM core. We have layer 2 security through integrated MACsec, once again on all ports, the capability to support authentication, encryption, and decryption. And a key piece also is functional safety. So the ability to support the ISO 26262 standard with collateral and ASPICE software is a key goal for our solution. So we are targeting ASIL B support for our third generation automotive switch solution, and we'll talk more about the ASPICE software, but we do support ASPICE level 2 today and driving towards level 3 in the future. Okay, so we are sampling both versions of our third generation automotive switch today. So if there's interest in that, we'll give you contact information. You can reach out, and we do have a development platform as well that we can provide for evaluation and proof of concept purposes, performance reviews, and so on. So we can once again provide information on that. That's not an issue. High level, once again, returning to Marvell's strength, which is our long-term investment and leadership position in automotive Ethernet. We continue to extend our in-vehicle network leadership with our third generation product, the 5152 and 5192. But you can see the long history that we've had with automotive, starting with in 2005, essentially, with our storage solutions that we provided to automotive. Then we provided wireless. And then from there, essentially, we've been providing automotive Ethernet solutions, multiple generations of 100 base T1 PHYs, as well as gigabit PHYs, and now our third generation automotive switch solution to enable basically a safer driving future. Okay, so my last slide is just a quick summary of our Bright Lane automotive Ethernet product portfolio. The key takeaways is, we're extending our automotive leadership position in secure in-vehicle networking for Ethernet. We're the industry's most advanced and comprehensive security and safety functions solutions are implemented into that third generation. We're the first to integrate MACsec. We have into our physical layer transceivers. And we do have our dual core lockstep CPU and EHSM to once again manage the security and manage the keys and key storage. And our ASPICE software and our ISO 26262 support collateral is really designed to help the tier ones, our third-party partners, and our OEM partners to achieve their functional safety and quality and long-term reliability goals. Okay. So I'm going to turn it over to Ilya now to go through his portion, and I saw some questions pop up, and we'll be ready to address those questions, I believe, at the end. Okay?
Good. Thank you, team, for your part. Now let's move to the next one. And I would like to start, I would like to make a step back. So how was the switches considered before in in-vehicle networking? Usually the switches were considered as, let's say, a kind of peripheral of the microcontroller, and everything was done in the microcontroller. Where I mean everything like the routing, the security, the gateway functionality, which took a lot of resources from the microcontroller, as the switches were kind of like an extension with a bigger amount of ports, Ethernet ports. But now and definitely in the future, what if there will be a special, let's say, intelligence inside of the switches, which would be able to take over those, let's say, networking stuff. And then we can start to reconsider the switches as a network coprocessor, because first of all, in the all modern switches, there is a dedicated CPU which can be utilized for to quite high extent. For example, even the first Marvell switches in 5050, there was a CPU inside single core. Now in a FEAR and 5192, there is even 2 CPUs inside in a lockstep, and we can do way more things with it. For example, if we go to the next slide, the network features can be taken over by the intelligent switches, which leads to certain advantages. So no additional load on the MCU for high-level network features. It leads to a faster and parallel startup, because then, for example, if we have a big switch with 16 ports, in the old times, this switch was initialized by the microcontroller, and not only the switch itself, but also the transceivers inside. But with intelligent software, you can do it in parallel. So when the microcontroller is booting up, the switch can also boot up, and then the switch, independent from the microcontroller, can configure the ports. And it gives us another advantage, which helps to, let's say, to separate the MCU, separate the application from the network. What can Marvell offer besides the switches? They can offer also a certain SDK, which can help to utilize, let's say, the hardware features, native hardware features inside, and with possibility to extend from Polaris up to Titan. But those, let's say, those software features, they're covering the main hardware features, but they can be extended. And it's exactly what we are doing in Electrobit. We extend those features with our Ibizo Neo switch core. It's a new product introduced in November last year, which basically leads to utilization of the internal CPU inside of the switch with, let's say, highest automotive industry standards, high efficiency and deep integration into the hardware feature, which can help to do routing, firewalling, intrusion detection and prevention, switch control and configuration, and many more. The switch core, it has actually a modular structure, which allows, if needed, to implement an additional modules inside, such like a logging or communication over TFTP, and so on and so forth. How does it look like? If we look at the architecture of the, let's say, hardware and software, you can see that on the microcontroller side, on the host MCU, there is just a classic author-defined module, which is called Ethernet switch, which helps to communicate with the switch firmware located inside of the switch, which gives us a possibility to have a special software on the switches, very dedicated one, and still maintain the, let's say, standard Autosar workflow to have a communication, Autosar specific communication on the microcontroller side. Because our position is that, yes, in some certain way, this software for the switches has to be compliant to the Autosar standard. However, the switch is not like a standalone ECU. because the switches, they usually the CPUs inside, they don't have that much flash memory, they don't have such powerful CPUs, and implementing the whole Autozar stack usually doesn't make a lot of sense, for our opinion. We may consider it like, let's say, a switch at your home, a router or whatsoever. You don't have the Windows or Linux, but you have a specialized software on it with specific interfaces which are running over the web browser in your Linux or Windows machine. So it's easy to communicate with the switch, and the switch does its way with all the internal hardware features and also with the specific software. We usually provide our switch core as a binary file, but it's a usual way, and if there is a request, we can provide it as a source code, which is similar to the Autozar business. But we did it in a purpose. We did it as a binary file because our goal is to provide to you the software which is the fastest one, which is the most efficient one, which uses all the hardware capabilities. By providing it as a pre-integrated binary, the modules inside of this binary, they are already pre-configured in such a way that we can provide you the best functionality. However, there are post-built configuration capabilities of this binary file. So the whole network-related things you can configure in our configuration software Trezor Studio. It's exactly the same software where you would configure the classic Autozar stack on your microcontroller. So there is a single tool even for a specialized software, which is, for our opinion, quite convenient. What are the features? Because before it was a high level, and I want to show you a table which shows the, let's say, cross comparison between the SDK provided by Marvell, the functionality provided by SDK from Marvell, and the functionality which can be provided by the switch core from Electrobit. And here you see the table. So there are features which are marked with a blue colors. They require special hardware. Let's say special hardware capabilities, but they're all present in Marvell. However, with the switch core, you see that we are adding a configuration updates over the Ethernet, internal and external 5 configuration. We also add a capability to configure the switches which are attached to the switch with our switch core, with our firmware, and then in this case, the switch with firmware from Electrobit behaves somehow as a host microcontroller for configuration of other switches. We have an Autozar defined interface on the host. We have post-built configuration changes, IPv4, IPv6 layer 3 routing, firewall, autonomous health monitoring and reporting, Idsm compliant pre-filtering and reporting, intrusion detection and prevention as well. And I would like to quickly stop on a couple of features like Idsm compliant pre-filtering, reporting, and intrusion detection, and in more details, how, for example, the autonomous health monitoring can be done. So Idsm compliant pre-filtering. In latest Autozar standards, there was an Idsm module defined, which is responsible for, let's say, filtering of security events and providing, let's say, logging and so on and so forth, and update the information or pass over the information to the IDSR. And what we do in our switch core, if there are some security events which were detected either by software or by the hardware feature, like the TCAM rules, we already pre-filter them in Idsm manner. So, and then we can report it to the host where the main Idsm module is located, which means even for the things which are security related and were detected inside of the switch hardware, those features we already, let's say, take over responsibility for it, and we already pre-filter and identify it. So then there are no additional resources on the MCU for those events consumed. Intrusion detection and prevention. We are partnering with cybersecurity company where we are trying, we will integrate the library, which will allow us to go to up to the layer 7, as far as I remember, in let's say deep packet inspection, with certain. And we are doing in such way that it's very flexible, because some parts can be checked by hardware nearly in full line speed. Some parts can be checked maybe by electrobit software, or some parts of the frames, or even the whole frames, or with a certain pattern, can be checked by this cybersecurity library up to the highest level. And then we cover very, very broad spectrum of different use cases. And now a couple of slides about autonomous health monitoring and reporting. Quite often, at the microcontroller on the health side, you want to check the health of your network. And by checking the health of your network, usually in a, let's say, standard way, standard fashion, the microcontroller through the Ethernet switch driver module initiate a specific register readouts to get the values, to recalculate the values, and so on and so forth. And then in case of fear, with 9 ports, or 5192 with 16 ports, it might be quite a long procedure, relatively long procedure. But what if those data can be captured by the software which is running inside of the switch? It will offload the microcontroller. It will speed up the whole process, because there is no need to go over the connectivity between them, either over SPI or the Ethernet. And then this data can be kept or pre-processed already internally. And it's exactly what we are doing. So we collect with the switch core, we collect the health data autonomously and provide it to the host as a service. And basically we can do, there are multiple of advantages besides the resource consumption. So we can make it based on a, let's say, some certain trigger from the host that I need this information right now, please provide me. Or we can do it in instant kind of a synchronous way, that, for example, we can provide this data every second, or every 500 milliseconds, or every 2 seconds, depending on the requirements. And then there is another advantage. For example, you've developed, I don't know, like the integrator or tier 1, you develop the whole microcontroller. And then you have one type of the switches attached. And if you have this in, let's say, standard way, you want to get the health data, then you need to know the specific registers. You need to write, to know how, you need to write the specific commands and so on and so forth. But there might be a, let's say, situation where during the design, there was a decision to change to another device, to a bigger one or to a smaller one. But then it means that you need to change your code on the microcontroller. With our interface, with our approach, you will not feel the difference, because it will be the same SAM IP interface. You will get more or less the same data, but let's say from different types of the ports. So it's adding to you a kind of freedom to operate, to change, to try something new. And the same is applicable not only for the, let's say, the hardware configuration, but it's also applicable for the software configuration. I mean, you can do certain, for example, during already operation, when you need to make an update of the vehicles which are already on the road, you can just change a couple of parameters, and then instead of, let's say, only the port status, you can get the temperatures, you can get the amount of drop frames. If there is, for example, you've got an update in the car of the, let's say, cybersecurity mechanism, where you need to check all those things, not only the link status, but also the counters and so on and so forth. With this approach, it can be implemented in a way faster way. And there is another advantage, which so far we were talking about the classic AutoSAR. But with this approach, it's actually possible also with the SAM IP, it's also possible to operate with adaptive AutoSAR, which means that the determinism of the classic AutoSAR on the performance with the classic AutoSAR can be shifted to the adaptive AutoSAR, and then there is a easy integration because SAM IP is a very well-defined interface, and we can do it. So, was it already done or not? Those features, are they used or not? And on the next slide, I would like to show you the real use case, a real example, which is already on the road since multiple years. And the switch core was used on Marvell switches. And it was used for VLAN filtering, participated in the network time synchronization. It did layer 3 IPv6 routing in software and health monitoring. VLAN filtering was used, for example, with the help of the TCAM rules, which led to way higher performance in terms of, let's say, in terms of speeds, and also way lower microcontroller or the host CPU load. And then finally, a couple of success stories. So with our switch core, we are already in a German OEM market with centralized E2E architecture in HPC network node. We are already there with Marvell switches. The same is applicable, but for the main architecture in RTC network node for North American OEM. And of course, EV startup in domain architecture in the RTC network node, we have our products and as well on Marvell switches. And what I would like to mention is that with those success stories, we are actually covering right now the full portfolio of Marvell switches. Not with the last one, of course, the FEAR one. And all of them are in production ready quality. Some of them are even on the road. And finally, just a small summary. With the Neo products, we are providing the future-proof solutions which are capable to solve not only the current problems, but also the problems which we will see or which we will face in the future. We optimize the computational resources. We offload the microcontroller. We provide more functionality, and it can be used, let's say, on the same microcontroller, on the same architecture, but with a clever utilization of resources. So we are road tested. As I mentioned, there are already cars on the road in mass production program with the software from Electrobit with the software from Zonal product line. We have 20 years of experience. We cooperate with multiple hardware vendors, and Marvell definitely is one of our strongest partners in this domain. And we also finally reduce the total cost, because if you're deciding to use a switch and you want to have a certain amount of functionality, most of the network related functionality can be offloaded to the switch, and then you can use either more functions on the microcontroller or even use a cheaper one. So that's it on my side. Thank you for being with us.
Thanks, everyone.
Thank you. Goodbye.